Okay, so here's this wonderful system here, right? Find the tension and the acceleration of it, right? Um, and let's see, the plane is frictionless, so that makes it a little bit easier. That makes the only force here the parallel component of gravity. So let's figure that out. mg sine theta is equal to 6.12 times 9.81 times sine of, what is this supposed to be, 28 degrees? Okay, so sine of 28. I'm just getting that from here. Okay, so here we go. So let's go 6.12 times 9.81 times the sine of 28, 6.12, 9.81. Okay, that's 28.1857. That's acting that way, right? Now let's figure out the force of gravity on this guy. Okay, that's going to be m times g. So 1.6 times 9.81. That's 15.696. Now clearly this thing's going to accelerate this way. This parallel force is bigger than the weight. So this guy's going to slide down the plane, dragging this guy up. So let's guess that the acceleration is in the direction that it is going to go, right? There's my plus, and this is my plus. Okay. And now the other forces acting on this are the tension going this way, right? And then the tension's also going to act up on this guy. Okay. So if we set up our F equals ma, so now we've calculated all the forces. We've drawn arrows and all this stuff, right? Okay. And so let's set it up for the 6.12 kilogram object. We've got, if this is positive, this guy's positive, this guy's negative. So we've got 28.1857 minus t is 6.12 a. And for the 1.60 kilogram object, we've got t. I drew these arrows the wrong length, right? This arrow should be longer than this arrow, right? Okay, so let's see, 15.696. Okay, and then that equals 1.6 times a. And we don't know a and we don't know t. We'll do the same thing we always do, though, with these things, is just add them up, right? So 6.12 plus 1.6 is, what is that, 7.72? Is that right? 6.12 plus 1.6. Indeed it is, right? And then if we add these together, we've got negative t and we've got positive t here, right? And so the t's go away, but we do end up with 28.1857 minus 15.696. That equals 7.72a. And then, of course, we can just divide both sides by 7.72. And we can get our a. Okay, so let's see, parentheses. Minus 15.696. Right parenthesis divided by 7.72. This is 1.617 meters per second squared, where this guy is accelerating this way and then the down the plane, right? Or the mass is accelerating up. That's why the answer is given that way, right? And now we want to figure out what the tension is in there. My favorite one for tension would be this guy here, where tension's already positive, right? So that means our tension is equal to 1.6a. So our a is 1.617 plus 15.696. Okay, so that guy times 1.6 plus 15.696. And that is 18.2846. Okay, so that's this answer here, right? Okay, but now we're not done yet. Let's just double check. Let's make sure that it works in this equation. So we use this equation to find our tension. Now plug it in. We've got one more equation here, right? So let's see if we plug this in. If we go 28.1857 minus the tension 18.2846, does that equal 6.12 times 1.617? Of course, they're not going to be equal because these numbers are rounded, but the question is if they're noticeably different, then we've got a problem, right? Okay, so 6.12 times 1.617, that's 9.90. Okay, and then this side here, 28.1857 minus 18.2846 is 9.90 roughly, right? At least the three sig figs, these guys are the same, right? Okay, so that means that we likely found the numbers that make these both correct. Yay. Okay, so again, step one, you calculate the obvious things. If there's a mass on the plane, find the parallel force. If there's friction, find the force of friction between the object and the plane, right? If there's an object hanging on a string, find the weight of the object, right? Then you set up F equals ma. Don't forget that the string pulls with the tension. That's the force, right? We neglect the pulley, so the pulley doesn't change the tension. Tension here is the same as the tension there, right? So we set this up. You have to decide which way it's going to accelerate. This way is positive. This way is positive. Set it up, and then if you do it right, you'll have a positive tension. Right? You have a positive tension. That is, tension causes the acceleration, and then you'll have negative tension where it like inhibits the acceleration, right? You'll always be able to do it. It'll always end up being some expression like this where it's force causing acceleration minus force preventing it, all divided by the sum of the masses, right? When you find the acceleration, plug it into one of the equations and get the tension, and then plug everything into the last equation and see if it works.